All right. Well, good afternoon, everyone, and welcome. My name is Zakir Jaffrey, and I'm the Environmental Information Coordinator and Project Lead at the Commission for Environmental Cooperation, or the CEC. So I'm very excited to talk to you today on this webinar on continental mapping tools for today's GIS enthusiast, how CEC mapping products can help you think outside the national bounding box. So I'm also joined by my colleague, Ricardo Llamas, a geospatial expert that works closely with us on much of our work and products. And you'll hear from him a little later in the talk. Before jumping right into it, I do want to remind everyone to please select your language of choice using the interpretation icon at the bottom of the screen. And be sure to select mute original so you don't hear us speaking English if you're selecting French or Spanish. Also note there's a chat section where you can introduce yourself and speak with some of your other colleagues and attendees on the line. And there's also a Q&A section where we encourage you to ask any questions you have throughout the presentation. And we'll have time at the end allotted to answering those questions. So feel free to keep the questions coming throughout. All right, well, with that, we can jump into the outline. So first, I'll talk a little bit about what the CEC is, and then I'll introduce the Atlas and the North American Land Change Monitoring System project. And I'll talk about the core objectives for this work. I'll try and spend a big part of my section on some of our products that we have available and how you can access them before passing the floor over to Ricardo, who will tell you a little bit more about the integration process for a couple of our data sets. And then we'll end with some next steps before going to questions. All right, so the CEC. So I just wanted to provide a brief summary for some of you that are maybe less aware. The CEC was created in 1994 to enhance trilateral cooperation on the North American environment among NAFTA partners. That's the North American Free Trade Agreement. And as of 2020, the CEC is now recognized and maintained by the Environmental Cooperation Agreement that's parallel to the new free trade agreement between the three countries in North America, Mexico, Canada, and US. So as I'm sure many of you know, the CEC has been supporting trilateral collaboration for over 26 years now on a wide array of topics. And these topics are informed through 5-year strategic plans that provide this thematic framework for the cooperative work that occurs. The cooperative work is implemented through trinational activities under 2-year operational plans. So that essentially means that most of our project work spans 2-year project cycles. So these projects are carried out by the CEC Secretariat in Montreal, Canada, in collaboration with steering committees. And these are expert groups that consist of federal government officials from the 3 countries, but many projects also benefit from involvement of technical experts from state and municipal levels of government, the private sector, industry, and academia. So with that, I'll dive into the North American Environmental Atlas. And from now on, I'll just refer to that as the Atlas. So this is a mapping tool that supports research, analyses, and management of environmental information in US, Canada, and Mexico. So it assembles cartographic data, including maps, documentation, and interactive map layers on a wide array of themes, from standard reference layers to ecosystems to economic activities. Notably, it's also a vehicle for collaboration between agencies in the 3 countries to work together to achieve continental approach to map production and decision making. So it's important to point out one of our key outputs is our collection of over 50 geospatial mapping products that are available free to the public and anyone who's interested. All right, so this slide is actually just here to scare you. It's a long-winded timeline that we're not going to go into in any detail. But the key takeaway here is that the CEC Atlas was established in 2003 and has been around for a long time with many map publications and updates through the years. Also, an important point is from 1995 to 1997, the CEC convened a North American working group made up of a multidisciplinary network of over 50 experts from the 3 countries. This included geographers, ecologists, cartographers, and they were tasked at mapping North America's terrestrial ecoregions. So this terrestrial ecoregion map was originally published in 1997 as a paper map and report, and is important because it acted as a precipitating factor that sort of led to the key need for why the atlas was sort of brought forward. So I think as a lot of people who are tuning in here today probably know, information and data are often very confined to the boundaries of the institutions that are mandated to create them. And so the key problem or challenge we have with a tunnel vision approach to mapping products is, of course, ecosystems aren't delineated by jurisdictional boundaries. So this doesn't only, result in the mismatching of ecosystemal boundaries at the border, but another key challenge is in regards to the classifications, the terminology, and the standards that we use to refer to them. So when we put, the 3 national maps of ecoregions together, the boundaries didn't match up, as you can see, because the countries were using totally different standards and naming conventions for how to refer to the same ecosystems. And so, of course, they had to work together to agree on a seamless classification scheme. And this is the result, as you see here. The agreed upon classification is a nested system in 3 levels of detail. So level 1 is the coarsest and divides North America into 15 broad ecological regions. And so those are the 15 different color gradients that you see there. Level 2 breaks down that level 1 into 52 ecological areas that are nested within the level 1 system. And then finally, the level 3 is a hierarchy that defines 182 even smaller ecological areas that are nested under level 2. And of course, part of this data publication is a report that defines each of these 182 classes and then gives the breakdown of what the definition of that class is. So this is just a story about one of our mapping products to highlight the key need for a continental approach when we map ecosystems. And I'll get into how you can access this data a little later in the presentation. All right, so now I'm gonna jump back a little bit and talk about the North American Land Change Monitoring System. So from now on, I'll call this NALCAM. So if you hear that acronym, you know I'm referring to this, this term. So NALCAM is an integral part of the Atlas and involves an ongoing collaboration among agencies in the 3 countries to monitor land cover and its change over time. So it provides valuable change indicators to help the 3 countries better understand the dynamics of land cover and can be used in analyses for decision-making with regard to ecosystem management and conservation, climate change mitigation and adaptation, and urban sprawl. And it's important to point out here that NALCAM produces some of the Atlas's flagship data sets using MODIS, Landsat, and RapidEye data. And this actually includes, the highest quality available land cover and land cover change data that is out there for North America from 2005 to 2015. And I'll go into detail on some of these products in a few moments. And this project is made up of experts from NRCan, USGS, CONABIO, CONAFOR, and INEHI. And it's been an ongoing CEC project since 2006. All right, so I'm gonna go to the core objectives. So I think one of the main core objectives that we have is to provide a forum for collaboration between data scientists, mapping agencies in the 3 countries toward the creation of geospatial mapping products. I think in the absence of the CEC, many of our partner agencies and the groups that we work with wouldn't have the opportunity to collaborate on projects outside their national borders, as it's often beyond the scope of their agency's mandate. So each data set in the Atlas really represents a unique collaboration between the agencies in the 3 countries that house that data nationally or otherwise. So that being said, our go-to experts and agencies for land cover that you see pictured here are a different group than those involved in our work toward the North American forest data set, for instance. And it can also be a little more nuanced than that, as some of our data sets also involve collaboration at different levels of government. One example is our blue carbon work that uses a mix of global, national, regional data, as well as information from academia. And here's some pictures from our 2006 meeting when the terrestrial ecoregions data was first being updated and digitized. And as you can see, it was a very manual process. And I think one of the things that's interesting for projects that span this length of time is witnessing how the work we do changes accordingly. So as our technological landscape has shifted since then, so is the landscape in which we collaborate. Here's some photos from a handful of land cover meetings through the years. And I think an important part of any successful collaboration is to ensure, frequent communication. It's important to provide a forum and space for scientists that are part of the group to share methods and information and meet frequently. So we try and do this on an annual basis. In this picture, there are photos from some of the first meetings in 2007, as well as one of the more recent ones last year. And we also try not to let the pandemic stop us. So here's a photo from our annual meeting with the NALCAM group, which took place last week. All right, for core objective number 2, this one's really important and revolves entirely around a lot of the people that are tuning in today, the users. So a main goal of our work is to get our data in the hands of researchers, students, and GIS users that have a need or interest in North American continental analyses, or anything that involves, cross-border work. As you can see here, we have 3 main access points for our data and tools. The first is our Atlas Viewer, and this is an interactive platform where users can explore and download our different data sets that we have available. And we just actually had an update earlier this year, and we're pretty excited about the revamp, as I think it's really helped to make access way more intuitive. We also have a basic map files page that you see there. And this is just a tabular view of all the data we have available if you know exactly what you want and want to just go grab it quickly. And finally, we have several interactive platforms through ArcGIS Online and Google Earth. And these are places where users can learn a little bit more about some of our products and projects before downloading the data directly. So as I mentioned, we have over 50 data sets that are part of the Atlas. Here are just a handful of some of our reference layers. You see things such as elevation, glaciers, sea ice, lakes and rivers, watersheds, roads and rail networks, and population density. Some of our ecosystem layers include forest, wetland, marine ecoregions, protected areas, and priority conservation areas. So I don't want to list off everything. I think it'll be better for us to dive in a little bit and then maybe give you all an opportunity to just go to our interactive viewer and check it out for yourself. We often also use our data to support other project work and outputs at the CEC. For example, we created this graphic for the CEC's recent Taking Stock report. So here we're using our watershed layer alongside data showing industrial facilities reporting releases to water. And doing so allows us to visualize the location of potential pollution sources in a given watershed. So here specifically, we're investigating releases to water in the St. Lawrence River Basin and highlighting sewage treatment facilities. Some of our data sets are also informed by other project work at the CEC. So for instance, here, our blue carbon data is created in partnership with the CEC's Blue Carbon Project and Steering Committee. And this is something that Ricardo will talk a little bit more about in a little bit. We also provide mapping support to other projects in other ways. So this is one that also helps, inform some future data sets for inclusion in the Atlas. So we work closely with the CEC's Drought Monitor project to produce this ArcGIS Online map of the Köppen-Geiger climate classification of North America. And this is something we intend to add to the atlas in the coming year. All right, so I think now is a good time to jump into the viewer so I can show you around just a little bit and maybe have you be a little bit familiarized with it. So when you arrive at the page, you'll find a pretty intuitive interface. The top left, you can select between our 6 thematic categories. You see reference layers, terrestrial ecosystems, marine ecosystems, pollution and waste, human influence, and climate. And at the bottom left, you'll find a pretty user-friendly legend where you can arrange the order and transparency of your selected layers. If you click on any of the themes of interest, within that you will be able to select a data set that you're interested in learning more about. You can click the read more option to be able to go to a specific landing page on that data so you can learn some more about it. Or you can click download to access the data right away. So here I've selected our watersheds data and I've pulled the transparency back a bit to allow our political boundaries data to pop out. And one thing I want to point out is that, we're a trinational organization, so all of our data layers have trilingual legends. So here's an example of our watersheds level 2 layer. All right, so here I've selected our forest data as well as land cover. And then I go into pollution and waste and select our power plant emissions for a particulate matter under 2.5 micrometers. And once you have selected some layers that you're interested in downloading, as I mentioned, you can click download right near the selection of the data set, or at the bottom of the legend, you'll see an option there. And when you do that, you'll get a little pop-up that'll show you a few different options for different data formats that you can access, or you can click the metadata to learn a little bit more about a particular layer. All right, I also mentioned that we have some ArcGIS online story maps. And here's one we actually released earlier this year. And it does a great job, walking a user through the NALCAM project, and Noel explains what land cover is and the many applications of it before diving a little bit further into it. It also gives you a great idea of what each of the classes are and their full distribution throughout the continent. So I highly recommend checking that out if you want to learn more about the project. All right, so I mentioned this earlier, a lot of our key data sets for the Atlas come from the NALCAM work. And the first few products that were associated with the NALCAM group were created using MODIS imagery, and that's at 250 meter resolution. And this includes land cover for 2005, 2010, and a subsequent change product between the two. In the last few years, we've been working closely with using data with Landsat and RapidEye, and that's resulted in products with a much higher spatial resolution, a 30 meter resolution. So our 2010 Landsat data was released late 2017, and just earlier this year, we released 2015. And just today, we are releasing our land cover change 2010 to 2015. So I'll show you a little bit more about that and where you can get it. But before doing that, I want to illustrate that big increase in spatial resolution that we're experiencing between MODIS and Landsat. Here's an image that really well depicts that for the Vancouver area at a relatively zoomed out level. And you can really still quite well see what an increase in spatial resolution we're experiencing with this change. And here's a similar example for Mexico City. And of course, on the left is the MODIS data, and on the right is our new Landsat products. And as I mentioned, today marks the launch of our land cover change product at 30 meter resolution. So you'll be able to download it right after our talk. We're officially launching at 2. And this graphic here, you can see some of the summary stats from the changes we're seeing between 2010 and 2015. I know Ricardo will talk a little bit about this, but as you can tell, one of our largest class conversion is forest loss. All right, so we've prepared a few stories that highlight some of the key landscape changes that we're seeing in the data. And in this change here, we're witnessing the impact of the 2014 wildfire season in the area surrounding Yellowknife, Northwest Territories. So you can really see how significant a loss of forest was experienced in the Northwest Territories at that time. In this example here, we're in the coast of Sinaloa in Mexico, and we're seeing quite a significant change of areas that are classified as a wetland in 2010 that are classified as water in 2015. So it's quite a substantial region of change along the coast. And then further investigation reveals that these habitats are actually being flooded to make space for shrimp farming, which is a growing industry in Sinaloa. Right now, we're also building an ArcGIS story map to walk you through some of the change stories that we just mentioned here, as well as a handful of others that you'll see in the near future. So the great thing about this tool is that it really acts as a great opportunity for users to view the data at a very fine resolution without having to actually download it. So users will also be able to click on change polygons to get details on the precise land cover change transitions that are occurring. So the change polygons are what you see in the image in purple. And the area that's red, that's the class color for urban space. So in the change map, you see this area here. If you can see my mouse, this is a little slider, and users will be able to slide between the 2 years of data. So on the left of the slider, you see 2010 imagery, and on the right, you see 2015. So as I switch between them, you see quite a bit of urban growth around the Dallas-Fort Worth area, particularly in the northern part of the city. And if we zoom in a little further, I'm going to zoom into that yellow space over there. You'll see that you can really see quite a bit of detail at the level of the urban subdivisions. So you can see there was quite a bit of urban growth. And if you click on any of these polygons, you'll see, in 2010, that specific area was classified as cropland. And in 2015, it turned into urban. So we're planning to launch this shortly, and please stay tuned to check it out. And with that, I'm going to pass the floor to Ricardo, who's going to go into some more details about our integration process for land cover and blue carbon.
Well, thank you so much, Zakir. As everyone has seen, all this amazing work that CEC has been doing integrating these continental maps, or at least for the level of the North American continent. It's been a great effort that also brings together many institutions from the 3 different countries. And in this case, one of the most important projects that CEC has been supporting over the years is the North American Land Change Monitoring System, NALCMS, NALMS. So it has like many different ways to say the same acronym. And today we're going to show a little bit of the integration process for this North American land change map. So the next slide. So, and in this context, so it's basically 3 countries and 4 maps coming together. We are saying 4 maps because the US is delivering independent maps for Alaska and the conterminous United States. And the integration is also being carried out integrating Canada and Mexico. And one of the main advantages of this continental product is that it's standardized in spatial resolution, 30 meters for the 3 countries. Also, the coordinate reference system is standardized for 3 countries, the Lambert-Azimuthal equal area. I will show more details about the advantages of this coordinate system. Also, the land cover classification scheme is the same across the 3 countries, which is a great advantage when like the 3 countries independently, they provide these land cover classifications with different features and different sources. Also, the standardization of the cross-border land cover patterns, and also the minimum map unit. Next slide. So one of the main advantages now in this new product is that the resolution has been improved a lot, as Zakir was mentioning, coming from 250 meters from the MODIS product using Landsat data and Rapid Eye in the case of Mexico from 5 meters and then being resampled to 30 meters. Now we can see a lot of detail. We can see even the road network, and this offers a great input for land change detection. Next slide. So then coming into the details of this integration process, and this is one of the most important examples, taking into account the importance of the land cover map. So one of the key features is the coordinate reference system. We are using this Lambert azimuthal equal area, which is actually the standard reference system for the North American mapping efforts of CEC. This one is really useful because it maintains the land features, their true relative sizes. It also maintains a true sense of direction from the center. And it's also useful for accounting areas based on squared pixels. So in this case, it's 30 by 30 meters, but it can be also in other resolutions, coarser resolutions we have been working on. An interesting fact about this projection was developed in 1772 by Johann Lambert. So it's interesting that we are now using cutting edge mapping techniques based on all cartographic knowledge. So it's still something that it's reliable for making maps. So next slide. So one of the other features of this project is that the land cover classification scheme has been standardized for the three countries. This legend was defined based on different efforts of experts from 3 countries. And it's been the outcome of different meetings back in the years. And there are 3 levels of classification. The level 2 is the one that is delivered by CEC, and it's the one available for the users, although level 1 can be also requested. It's a more generalized classification, and the level 3 is country specific. So those are basically the INEGI classification in Mexico or the USGS classification in the US through the NLCD project. And also this legend also meets international standards such as the FAO land cover classification system. So these 19 classes basically describe in a very general, but also at the same time a specific way, the land cover distribution in North America. Next slide. And some of the integration challenges that CEC is facing in all these integration products for North America is all these cross-border spatial mismatches. You can see here some of the initial inputs that CEC has been working on for the integration of the land cover map. This is an example between Manitoba and Minnesota. You can see the before and after. So the integration process actually allows CEC to review this data and also take it back to the experts so they can revise and evaluate this land cover classification, and then can improve this classification in order not just to meet the this kind of continuity across the border, but also to make it more accuracy based on information from both sides of the border. So next slide. So this is another example also in Manitoba and Minnesota. You are seeing the before and after. So then when CEC is identifying these mismatches, so this data is taken back to the experts. So USGS or Natural Resources in Canada, they can revise these areas and then can provide more accurate information in order to integrate a more consistent and seamless continental map for North America. The next one. So there is another example. This is between Mexico and the US in Arizona and Sonora. You also can see some of the changes in the before and after with this kind of discontinuity in the land cover patterns. And now how it looks after the revision by the experts from the institutions from the 3 countries. So next one. And something interesting, like sometimes we are seeing that there are these kind of non-natural patterns between borders. So it could be logical that maybe these changes are misclassified, or these areas are misclassified. But then also comparing this with the actual satellite data, you can see that some of these changes are actually real. You can see here in the border between British Columbia in Canada and Washington State in the US, like this line between forest, this dark green is forest, and then you can see these other colors, this kind of brownish color that represents shrubland, temperate shrubland. If you see the real image, you can see that actually that pattern is real, because these differences in the land management between countries actually sometimes they produce these kind of non-natural patterns and abrupt changes across borders. Next one. Also, some of the quality control that it's being carried out by CEC when integrating this data. It's taking a look at the classification, land cover classification, and seeing if there is some errors that needs to be corrected. So also this data is taken back to the experts, so they can also not just improve the product that it's going to be integrated in the North American product, but this is also useful so they can improve their national products and also take a look at these mistakes or these misclassified areas that could be artifacts in the final classification. The next one. Also some other steps in the cleanup process and correction of misclassified areas. In some cases, based on the use and methodologies based on satellite images, sometimes some areas are misclassified along the coast. This is an example in Mexico. So these areas also have to be cleaned up just to be sure that there is no water pixels along the coast, and so then we can define the boundary, having this limit between the length in the continent and the ocean, that it's also being delivered as background in the final product. Next one, please. So once the map is it's almost ready, and then the product is almost ready also for the public. So there is an important rule in cartography that sometimes so much information that doesn't mean that the accuracy is even higher. So that's why some cartographic generalization is needed. In this case, so the group, the NALCHEMEX group has agreed on having a minimum map unit of 5 pixels. So that means that all these areas that are connected by 8 neighbors in different directions, at least 5 pixels connected, are represented in the map. All other areas, 1 pixels, 2 pixels, are smooth and resampled to the dominant class in the map. So this offers also a more consistent and cartographic generalized product. Although CEC also offers upon request the product with no minimum mapping unit, or at least 1 pixel minimum map unit. Next slide. So this is the final product, that is the land cover product that it's being delivered by CEC. So now it's available in North America 2010 and 2015 at 30 meters, and also the 2005 and 2010 at 250 meters. Some interesting facts about this is that in this map at 30 meters, almost 24 billion pixels are being classified across North America. Just imagine the number of pixels, like 24 billion, that's something really crazy. And the amount of data that it's being detected from satellites, and also that it's all being offered to the users to perform any kind of analysis in this area. North America, it's around 21 million square kilometers. So this is a great effort bringing all these together. Also, this map also shows areas on two hemispheres at once, because of the westernmost parts of the Aleutians in Alaska. This file actually, so if this would be delivered in an uncompressed format, this would be around like 65 gigabytes. So, but CEC is delivering this in a compressed TIFF format that it's 4.5 gigabytes, and it can be almost instantaneously deployed on Esri software thanks to the pyramids that are also attached to the files. Next slide. But then for the users that don't want to work with this enormous file, and they want to work on very specific areas across North America, CEC is also delivering and providing these independent maps by sections in Alaska, Canada, CONUS, the continental United States, and Mexico. Next slide. And then having this information, having the land cover maps from 2010 and 2015, for instance, so CEC is able to assess the changes, or to provide the changes for these 2 years. So today, CEC is launching this 2010-2015 map. And this is for the US, Alaska, and the CONUS. This is based on the difference over for these 2 years, just subtracting the changes from one class to the other. And in the case of Mexico, they performed change detection algorithm, and then they extracted the land cover values within those change polygons over Mexico. And this was because Mexico has improved their land cover classification from the 2010 map, and then now having the 2015 map, land cover map as a baseline for the land cover in the future. So next slide. So some of the, so this land change product that it's being also offered by CEC offers not just the numbers showing the class in 2010 and 2015, but also shows in an attribute table what was the class, specific class in 2010 and 2015. So the users, they can extract like the information they need for the area they are interested in, and they can get this specific and useful information for all sorts of analysis. Next slide. So also, as Zakir was mentioning, CEC is a tri-national organization. So providing this information in 3 languages is also important. So this land change product offers also the description of classes in the 3 languages, English, Spanish, and French. And in the future, in the coming weeks, in the new story maps product that is going to be also released by CEC, some statistics, land cover change statistics will be provided. All these statistics actually have been derived from the products that are already available. So for those users who want to work on a specific area and also get these gains and losses by specific classes or by general classes, they can perform this analysis. Next slide.
Excuse me, Ricardo.
Yeah.
This is Eliana from the CEC. Can you please slow down a bit when speaking? Interpreters are having trouble following you. Thank you.
Okay, perfect. I'm sorry. So some of the statistics we are also having from this product, so we can get the area of loss and gain by a specific land cover classes and the percentages. All this information will be also provided in the coming story maps, but it can be derived from the products that are already available to download. Next slide. These are just some of the examples of the losses and gains by general land cover classes. You can see, as Zakir also mentioned before, one of the most important losses is forest loss, and one of the most important gains is shrubland and also grassland, as you can see in the next slide. So all those areas from forest, they were converted into grassland and shrubland. In some other cases, wetland, you can see like at this level for North America, it's barely visible, but just downloading the products that are available at the CEC website, you can zoom in and you can get this information at 30 meters resolution. So this could be very useful for any kind of analysis. In the next slide, just showing some of the other changes, urban and built up. It's just a little bit. Cropland, so basically in the Midwest in the US, some of the changes in gain, and also like in Mexico in different regions. Next slide. So just small changes. The classes actually that have the fewer losses and gains, water and snow and ice. And the next slide. And that's basically the product that it's being released today by CEC, and that can be useful. So future products also taking into account this North American integration, map integration, the North American blue carbon map that it's going to be updated by CEC in the coming year, and it's also in progress. And this one shows the distribution across North America of seagrasses, mangroves, and salt marshes. And this integration also brings some other challenges, as the spatial overlapped information from different sources, uneven availability of data across countries, different source features. Some of these data come from field surveys, some other from remote sensing techniques, and also some differences in reported accuracy. In contrast to the land cover product, where some institutions are working consistently on this, in the case of the North American blue carbon map, so CEC is bringing together many data sets from different institutions, global institutions. So it's more challenging to standardize this information in order to generate a North American map. So next slide. So the main data sources that are being collected by CEC, in seagrasses. For Canada, some global information from the WCMC, the World Conservation Monitoring Center, some academic institutions, and some other governmental institutions by province or federal institutions. In 3 cases, Canada, US, and Mexico. For the next slide. For salt marshes in the US and Mexico, so most of the data is coming from global data sources, and also some other national data sources are being expected. For mangroves in the US and Mexico, it's the same, some global organizations, some global institutions, and some other national organizations. In the case of the mangroves, CEC is still waiting for the Canada data, so that there is a data gap in mangroves in Canada. But so we're pushing to get those mangroves from Canada. So that's a joke. Okay, so next slide. And then one of the challenges in the spatial integration, it's how to put together all this information from different sources and with different level of spatial detail. One of the strategies could be coming global to local, then taking into account first the global data sources and then attaching the local data sources in the next slide. The other strategy could be going local to global, then changing the strategy and then keeping the maximum spatial detail that it's possible to achieve from this detailed information, and then adding some information from the global data sources. Next slide. And the way that this is being approached is by generating some draft maps with information CEC has now, and then providing this draft version to a group of experts to get some feedback on how to approach and how to get the best map possible. So this is just an example between the current version of the Blue Carbon Project and the draft version for British Columbia for seagrasses. The next one, please. This is some more examples for distribution between the current version and the ongoing version, the draft version of CEC. The next one, please. This is salt marshes in the Delmarva Peninsula in the US, in the delta of the Delaware River for salt marshes. And the next one, please. Some more examples. This is mangroves in the coast of Sinaloa in Mexico, the difference between the current and the draft version. The next one, please. And finally, all this information having these draft maps. So CEC is conducting 3 national experts meeting and workshops in Canada, US, and Mexico. So the experts from different institutions, they can revise these draft maps. They can also highlight or point out some data gaps. And also CEC is recording all this feedback from the 3 national experts to take advantage of that expertise in order to get the most accurate map as possible. So next one, please. I'm almost done with this. And then just future work is updating the North America terrestrial ecoregions, bringing information from different institutions in 3 countries, in Canada, US, and Mexico, basically federal institutions. Next one, please. And also some of the challenges are basically the spatial mismatches and inconsistencies. This is just an example in the boundary between Alaska and Canada, and how so this in some cases this can be easily corrected because these are just small areas and it's not that complicated to make these edits. Next one. And in some other cases the changes are really big, but because the agencies, these institutions in the 3 countries are updating their national data sets, changing from one class to another class, or from one ecoregion to another one nationally. So this data has to be also taken into account, and these changes have to be included and updated in the continental map. So next one, please. And that's the future work, and this is part of the challenges and the approach that CEC has when integrating continental data and providing to everyone in the 3 countries.
Great, thank you very much for that, Ricardo. It's really interesting to see how each data set is totally different in how the approach that needs to be taken to the integration process. And so now I just want to highlight a few next steps before we move on to some of the excellent questions that have been coming in. Of course, one thing we've both talked about quite a bit in the last 40 minutes is our new land cover change 2010-2015 product that will be available today. But along with that, we have our story map that's going to be launched on December 7th. So stay tuned. We're just putting some final touches on that to improve the efficiency of that. So that will be out shortly. Also, early next year, Q1, Q2, we have a couple data updates and publications coming out. Ricardo talked about the blue carbon data. So we hope to have that out probably Q1 next year. Terrestrial ecoregions, hopefully around the same timeline. And we also want to update our protected areas data set. So that was last updated 2018, and we're looking at doing another update shortly. We're also looking to update our reporting industrial facilities data that we have online, and that's part of our partnerships with our pollutant release and transfer register project at the CEC as well. So now I want to highlight a couple next steps for you all, everyone online. I think I gave a little bit of a giveaway a moment ago, but one thing we really encourage you to do if there's interest is to download our land cover change data set that is launching just in half an hour. And you can access it by either going to the CEC Atlas, so that's cec.org/atlas, and clicking the download button, or you can go to the NALCAM homepage and click on the first link there, and that will take you to a page that describes the data and provides the different formats that are available. Another next step for anyone that's interested is to get some updates. Whenever we publish, a GIS update to a previous data set or a new data set, if you subscribe here, you'll be the first to know. So that's cec.org/getmaps. And we're currently running a little bit of a raffle for anyone that's signed up by midnight tonight. So you'll have the chance to win one of 5 ArcGIS personal use licenses for a year. Or you'll also have a chance to win one of 30 North American land cover wall maps. So it's just going to be a random draw for anyone that has subscribed to Get Maps. Also, before I forget, we also would encourage you all to please fill out a survey that you're going to get in your email tomorrow. And I think Georgina is going to put it in the chat box as well. It'll help us improve webinars in the future, and also provide an opportunity for you to communicate some things that you would like to see. And that really goes into the final next step for you is to tell us about your North American geospatial needs. And that can be things that come up in the conversation now, or feel free to email me at any point in the coming days, weeks, or months. And with that, I think we can jump to questions. I've seen quite a lot come in, and I know we don't necessarily have a ton of time. So I do want to start by saying, if we don't get to your question, please reach out to me, and we're happy to follow up on anything that was discussed. One of the first questions that came up was from Daniel, and he'd asked whether we welcome partnerships with NGOs for further expanding data sets and information. Absolutely. I see that question was already answered by Georgina, but I just want to stress it for everyone else on the line. We're always looking for new collaborative work and new ways that we can add value to some of the products that maybe you build as well. We have some specific questions here. I see a couple people have asked about any thoughts or considerations toward using 10-meter Sentinel imagery. So just for everyone else, as we were pointing out, Landsat is at 30-meter, and Sentinel is a satellite that has data at 10-meter resolution. So that's actually one of the things that has been discussed in our group, the NALCAM group. But the core struggle with that, the core challenge is really one of human resources and computational capacities. Already, you know, as Ricardo pointed out, it's a huge continent. And I think, Ricardo, you said 24 billion pixels?
24 billion pixels for 21 million of square kilometers. So.
Yeah, so a core challenge for our continent is the sheer size. And some of our partner agencies is definitely a challenge is just human resources. So that's one thing that's being discussed. It hasn't been, you know, something that we've necessarily written off, but in the near future, it's not something that is being evaluated just from a practical standpoint. But Ricardo, is there anything you wanted to add to that?
No, I just wanted to say, I'm looking at some of the questions here, so I'm just trying to pick some of them because all of them are very interesting questions. I'm seeing Rogelio Corona, it's asking how the maps were validated and calibrated. All this information is provided in the metadata. Actually, there is an accuracy assessment process that has been conducted also for the land cover maps. So if you download the map and also you download the metadata, you can take a look at all this information and you can get the numbers.
Absolutely. Thank you for that, Ricardo. And that speaks to Anne Ferno's question as well. And you were asking specifically about some of the error and accuracy over grassland. And as Ricardo said, if you download the data, you'll see the accuracy assessment within that. And then that'll provide the error matrix where you'll get that breakdown on the level 2 class level. I see another question here. It's anonymous, asking how migratory phenomena are mapped at all levels. One example that's given is the monarch. That's a great question. We do have a layer on species of common conservation concern. And that's also actually, you know, an area of opportunity that we've been discussing internally, as we do also have a monarch project that's part of the CEC work. So one of the things we're looking into is, you know, updating that data set. Because the one that we have currently is a little bit older. And so we're looking into what data sets are available and what we can provide moving forward on that level.
So Sakura, I'm seeing here another interesting question. James Boyd says, when you speak about the conversion from forest to grassland, what time frame are you speaking about? Given 40 years or so, it might be forest again. So this is a very interesting question because we are showing changes for a 5 years period, but also the NALCHEMS project is a monitoring project. So providing maps in 2010, 2015, and the coming maybe 2020 map. So it's possible to evaluate these changes in this time frame, these time steps. So
for sure, no, that's a great point. Yeah, and just to let people know, one of the goals for the land cover group in the next year or two is to you know, evaluate opportunities for getting our 2020 land cover data set, and then subsequently having a 10-year change product. And that's going to present, I think, a lot of technical challenges. And I think one of the things that should be highlighted is I think positive change is quite a bit more challenging to demonstrate and to show accurately. So it's definitely an interesting concept that we're definitely looking at in the coming years. Mm-hmm. Hector asks what computer software is necessary to download and manage the information maps. So it largely depends on your machine and your needs and what you have available, because you do have options. There's a lot of people use Esri ArcGIS software for some of our shape files and some of the raster data we have available. You can also access QGIS, which is Quantum GIS, which is an open source free alternative to that. And many of our products also have you know, GeoPDFs, Google Earth files, so ways that you can access it even if you don't necessarily have mapping software. And another alternative to that is to actually just go to our interactive map viewer, so cec.org/atlas, and that's a way where you can actually move around, look at a lot of the data without having to necessarily even download something. And building off that, actually, Maria asks, can we download shapefiles or just TIFF? So the file format is really dependent on the data set. If we have data that's raster based, like land cover, it's often just going to be in TIFF format, especially our Landsat products. I think for some of our MODIS products, because we didn't have quite as much of a limitation in terms of the size of the files, we also provided a couple other options. Essentially all our raster based are going to be TIFF or Ertis IMG. For some of our other products that are vector based, then we have shapefiles available, MXDs as well, where you can download it and get a couple other ancillary CEC data sets that would help your work. The MXDs are great because they kind of already give you, the data, plus you'll get the political boundaries, Great Lakes, and a few other things, and set it up in a way that you can export it right away if you're just trying to build a quick map. But Ricardo, do you have anything you want to add to that?
I'm looking at all the questions. So for instance, I'm looking at these questions. Kevin McDonald is saying that, so the NALCMS 30 meters provides 19 classification types. And if we are planning, or CEC is planning to expand these types to introduce hierarchy. So in these cases, we mentioned there are 3 levels of classification. So it's, and the level 2 is, it's based on the level 3 that it's country based. So the level 3, it's basically the one that is developed by USGS in the US or in Mexico. And the level 2 is it's a generalization of this class. So it's available at the country level from the data sources.
Thanks, Ricardo. I see a question from David Solos. David says that he's been working on development of an interactive science atlas for UNESCO, Southwest Nova Biosphere Reserve in Nova Scotia. He provides the link for that. And he's asking if there's any restrictions on the use of our products for educational purposes. So great question. We are always 100% open for our products to be used at educational capacities. We just ask that the citation is listed accordingly. You can feel free to contact us for that, but we'll be putting all the citations of each data set on the landing page of each respective one. And we also really encourage you, if you are using our products for any purpose, we love hearing how things are being used, because we love to be able to showcase some of our users. So we would really appreciate like a quick email saying, hey, we're using this for this purpose. And it's a great way for us to document some of the great ways our products are being used. Ariel also asks, how often is it being updated? Also, an excellent question. And that really depends on the data set. But I would say that each data set's really at an irregular as needed basis. Some things do get updated a little bit more frequently. And it often will also depend on how frequently our source data is updated. So if some things have only been created once and there isn't a following update, then the update becomes a lot more challenging. But for things like protected areas, where each of the different data sources, for the most part, updates it on an annual or semi-annual basis, it becomes a little bit easier for us to try and work that into a schedule. David Solos also asks about coastal marine mapping. So that's another great question. I highly recommend checking out our marine ecosystem theme. We have a handful of products there, from marine ecoregions to protected areas. Blue Carbon is one that's going to be coming out. Sorry, just to clarify, Blue Carbon is already out. You can download the Blue Carbon 2017. but right now we're finalizing a pretty substantial revision to that. So there's going to be an update in the coming months. I want to make sure I don't miss anybody.
We still have many other questions, very interesting questions. So I think so we're running out of time, but there are so many interesting questions. Maybe we can answer the questions on the Q&A section for some of them.
Yeah, I'm trying to look through. Ah, great! I see. This is awesome. I see a question from Mason Croft, who we worked with for some of our protected areas updates. So Mason asks whether we've gathered the inputs for the protected area update, and asked if he can provide us with the new PAD 2.1. Sorry. Absolutely, Mason. Our goal is to do that probably Q2 next year, mainly because I know we get updates from all of Canada minus Quebec at the end of the calendar year, but Quebec's update frequency, I believe, is at the end of March. So I think what would make the most sense for our next update would be to do it after we have the most recent data from Quebec. So just shortly before that time, Mason, we'll reach out to you about pulling in the PAD 2.1. And for everyone else, PAD is Protected Area Database. It's the name of the US source data.
Yeah. Secure. There's here a question, and this one is in Spanish, but so I think so maybe you have more information about this. Raúl Vera is asking if as part of the activities of CEC, if training opportunities are being offered in some projects. And I know that maybe sometimes there are some opportunities to the public audience to be to participate in some of the projects of CEC.
That's a great question. I think that's also something that's done at a somewhat irregular basis and depending on project activities. So we did just hold a series of workshops for our remote sensing project where we were looking at some of the Earth observation work that's being done in the different countries related to different extreme events. So wildfires, flood, and drought. But apart from that, we don't have a regular system in place for training for GIS at this time. If that was the question, I hope I didn't misinterpret.
I think it's related to training activities in different projects and many different things as part of the CEC activity. So I think that's a good answer. Yeah.
Okay, great. And Raul, if I didn't answer sufficiently, please feel free to email and we can follow up on details.
Because I know if you take a look at the CEC website on a regular basis, you can see that there are a lot of opportunities for the public audience to participate in some projects and also offer some feedback.
All right, great. I also see a question from Susanna asking if there's a map of air pollution, PM 2.5, NOx, SOx. And so great question. And we do have a power plant data set that's available. So you can access that in the, if you go to the associated theme, I think under human influence. So I don't know, we're already over time. I'm scrolling through to make sure didn't miss anything. Sorry, everyone. Well, if I haven't answered your question, please do reach out by email. I'm going to go back on the slide here just so it's up again. So it's zjafry@cec.org or Z, depending if you're American or Canadian or however you pronounce that first letter there. And apologies if we didn't get to your question. And if we did and you have follow-up questions, please feel free to reach out. And again, really, this has been a great pleasure to have you all here today and to be able to talk about this work. And I look forward to engaging with you all in the future. And maybe just one last final reminder here to sign up to cc.org/getmaps to get updates anytime we add new data. And if you do it by midnight tonight, you will have the chance to have a land cover wall map mailed to your door, and you might be able to win a free ArcGIS license. And of course, you can download our data, our land cover change data at this site. So I'll leave this up as I say goodbye to everyone in case you want to jot anything down or jump over there right now. All right, well, thanks again, everyone. And I hope to speak with many of you in the coming days and weeks.
Thanks, everyone.
Take care, everyone. And thank you, Ricardo.
Yeah, it was awesome having the chance to share these exciting activities that CC is conducting. So I hope this is useful for a lot of users across the 3 countries.
Absolutely, me too.